Okay, question 3, packet 1. What is the sum of the measures of the interior angles of an octagon? First, we should write down what our n is. So n is equal to? Excellent. Next, we're going to write down the sum of the interior angle formula, which is 180 parentheses. Okay, and then open up another parentheses, n minus 2. Now we're going to write it one more time underneath, 180 open parentheses. You don't need those parentheses, but the next parentheses, open parentheses. And now we're going to write, we're going to substitute into n the number 8. And then 8 minus 2 is 6, so we're going to have 180 times 6. And then somebody could just call out the answer, 180 times 6. 1,080. No, not 1,800. 1,080. 1080. And that's letter. Thank you very much. Okay, number 10, same sheet. Find the measure of each interior angle of a regular polygon with 6 sides. So let's start by writing out what our n is. N is equal to. And once we have the n, we could figure out our exterior angle by the exterior angle formula, which is 360 over n. So now we're going to substitute in 6. So 360 divided by 6, which equals 60 degrees. So now we know our exterior angle, and the relationship between an exterior angle and an interior angle is that they are linear pairs and therefore supplementary. So to find the interior angle, we'll subtract the 60 from 180. Which leaves us with our answer, which is 120 degrees. So let's box our answer. You can box the answer. There we go. Number 17 on the same sheet. What is the number of sides of a regular polygon if each interior angle measures 135? Well, I prefer to work with exterior angles. Therefore, I'm going to subtract 135 from 180, which gives us 45 degrees. Now, once we have the exterior angle, we can easily put that into the exterior angle formula, which states that 360 degrees divided by the exterior angle is equal to our n. So we're going to just plug in the exterior angle here. 360 divided by 45 is equal to 8. Thank you. It's light work, everybody. Number 20. What is the measure of each exterior angle of a regular polygon having 15 sides? Well, here we're just going to use the exterior angle formula, which is 360 degrees divided by n is equal to your exterior angle. Well, here our n is the number of sides, which is 15. So we're going to substitute 15 into our n. And 360 divided by 15 is not 20, but 24. Meaning the correct answer is A, B, C, or D. Number 30, same sheet. Each side of a regular hexagon is represented by x plus 6. Which expression represents the perimeter of a hexagon? Well, since this is being declared a regular hexagon, that means we have a 6-sided figure, and furthermore, each of the sides is exactly the same. So if one of the sides is x plus 6, and you know that there are 6 equal sides, all we need to do is put that in parentheses, the x plus 6, and multiply it by how many congruent sides there are, which is 6. Now we're going to distribute the 6, and we're going to get, which is answer letter D. Number 2, worksheet number 2. Find the number of sides of a regular polygon if each interior angle measures 156 degrees. Well, as in most of these problems, I prefer to work with the exterior angle. So the first thing that we're going to do is subtract 156 from 180 degrees to find our exterior angle, which is going to be equal to 24. And then once we have the exterior angle, we're going to just plug that into the exterior angle formula, which says 360 divided by our exterior angle is equal to our n. So we're going to plug 24 into our n and divide, and 360 divided by 24 is equal to our n, which is equal to 15. A pentadecagon, I believe, is the name. Worksheet number 2, number 9. A regular hexagon is inscribed in a circle whose radius is 7. Find the perimeter of the hexagon. Well, one thing I just want to demonstrate here is that when you have a hexagon, something that's unique to a hexagon, that once you have a hexagon, even if you don't have the center, you could actually just take any of the vertices of a hexagon. I don't want that one. I'm going to go back. I'm going to choose this one. Any of the vertices and draw it to its opposite vertex. You will automatically find the center of what would be the inscribed circle. And then I could just rework this backwards and say, well, this is going to be the center of my inscribed, and do that. Okay, well, that's not perfect, but hey, none of us are perfect. So I'm going to ask my scribe, John, on the board to show us just very quickly what the exterior angle of a hexagon would be by dividing 6 from 360. 60 degrees. Okay, great. So if we know that the exterior angle, the angle out here is going to be 60 degrees, it also means that all of these angles inside right here are going to be 60. Go ahead and put some of those 60-degree angles in there. Yeah. And, for any polygon, once you know those interior angles right there at the center of the circle, basically the amount of degrees in which a hexagon would rotate onto itself, right? We also know that in a circle, all of these radii are going to be congruent to each other. So we look at all of these triangles at first as isosceles triangles, but if you have an isosceles triangle and the vertex angle is 60, and you subtract 60 from 120 and divide by 2, you soon realize that these other angles here are also 60 degrees. You can fill those in. Just for one of them is fine. Yep, you can do this one right here. And what you learn that is unique about a hexagon is that it's not created by 6 or 7 or 8 isosceles triangles, that a hexagon is unique because it's created by 6 equilateral triangles. So these triangles will have a side. You can put a little S up there. Yep, put an S right up there. That is equal to the radius. Put a little R right here. That is equal to the radius. So basically, if you know that the radius of a circle in which a hexagon is inscribed is 7, you also know that the side of the hexagon is 7. So go ahead, you can put 7 in any one of the sides. Right there is fine. And when you're finding the perimeter, all you're doing is multiplying whatever one side is by the amount of sides. So the perimeter, capital P, will be equal to 6, parentheses, 7. 6 times 7, which is equal to 42. So capital P is equal to 42. Okay, so we worked a lot this year with triangles, and we knew that when we had different angles, when the angles were not the same in a triangle, the one thing that we did know about triangles that enabled us to create equations is that the sum of the interior angles of all triangles is equal to 180. So it's important to remember that the sum of interior angle formula, 180 times n minus 2, works for all polynomials. So if you take 180 and parentheses, put 4 minus 2. And the reason why we're putting 4 is because a quadrilateral has an n that's equal to 4. So 180 times 4 minus 2 is the same as 180 times 2, which is equal to 360. Okay, that's very important that we know that number, because now we know that if we have 4 different angles of a quadrilateral, that if we add them up, we can create an equation by setting them equal to 360 degrees. If this were a pentagon, we would add them up and set it equal to 540 degrees. If it was a hexagon, it would be equal to 720 degrees. So it's important to know the sum of the interior angles of all polygons, not just regular ones. Now, in this particular case, they gave me the name, so I like to make a table over here on the side. So I'm going to put A, B, C, D over there on the left there. Just to normally would put capital letters, but okay. And then I'm going to put there what they're equal to next to each one. So angle A is 80 degrees. B is 2x. C is x. And D is 4x. And now I'm going to do some mental math. I'm just going to add all of that up here. And when you take 2x plus x plus 4x, that's equal to 7x. Plus 80 is equal to 360 degrees. Now I'm just going to solve for x. Next line, 7x is equal to 360 minus 80. 7x is equal to 280. Divide by 7 on both sides. And we get our x, which is equal to 40. Now I'm always going to go back up after I have my x in a geometry class and see what's the question. The question is find x. So we actually did that, so I can just box the answer and be done with it. But the question might be find measure of angle D, and then I would just substitute the 4 into the x and find that angle D is 160, that angle B is 80, and that angle C is the angle that is 40 degrees. Number 13, worksheet 2. If the sum of the measures of all but one of the angles in a polygon below is 785 degrees. What is the measure of the remaining angle? Well, the first step here is to figure out what the n is, because they're only giving me a picture. I need to know what the sum of all the angles are first. So first, we're going to count up the sides by putting little notches in them and count them as we go. 1, 2, 3, 4, 5, 6, 7. So I'm going to write on top of my page n is equal to 7. Then I'm going to find the sum of the interior by subtracting 2 and multiplying by 180. So 7 minus 2 is equal to 5. I'm just going to write down 5 underneath there. You're going to write down 5. And I'm going to multiply that by 180. That's really the formula right there. And 5 times 180 is equal to 900 degrees. Now, that 900 is a very important number because that's the sum of the angles of any seven-sided figure. Well, in this particular problem, they're giving me the sum of all but one, meaning they're giving me the sum of 6 of the 7. So I'm going to make, in my mind, x be the one angle we don't know. And I'm going to write an equation here on the right side that says x plus 785 is equal to 900. And then I'm just going to solve for x by writing underneath it x is equal to 900 minus 785. X is equal to 115 degrees. Number 16, worksheet 2. What is the number of sides of a polygon if the sum of the measures of its angles is 2,700 degrees? Well, they're giving us the sum of the interior angles, so we are going to write the formula for the sum of interior, which is 180 parentheses n minus 2. And we're going to set it equal to 2,700, equal to 2,700. Now we're going to solve for n. But instead of distributing, we know that if that's the sum of the interior, we could begin by dividing both sides by 180. The 180s cancel out on the left side. They cancel out. We drop down the n minus 2. And then we divide 2,700 divided by 180, which is 15. Now we go to the next line of the equation. N is equal to, n down, go down, n is equal to 15 plus 2. We bring the negative to the other side, and then we add 2, and we get n is equal to 17. Okay, I'm going to very quickly finish this video with the constructions of an equilateral triangle inscribed in a circle and a square inscribed in a circle. For an equilateral compass, circle, bring the pointer to any point on the circle and intersect the circle twice. Piano, please shut up. Then I'm going to put the pointer on one of the marks. And I'm going to come around and mark that there. Stop. And it's as simple as. With a square. With the square, I'm going to mark the center of the circle first. Now I'm going to put a point anywhere on. And I'm going to create a diameter through the center. And now I'm going to go to 1A, go more than halfway. On one side. So perpendicular